All right, thank you so much for joining us today. I know how it feels when you are taking final exams and you need to read the whole content before you go for the exams. I know how it feels, right? But the idea is that you need to relax, take a deep breath, and then try to revise and then, making sure that everything is fine. So we have 11 different questions that we are going to go through from different topics or subtopics, right? So stay here with me and let's go through together. I'm sure you are going to be fine and you are going to take your exam successfully. So let's start with the first question. But before I start, what you need to know is, when the question is given to you, it doesn't mean you need to go through the way I'm going through. You can start from question 11. If that one is the easiest one that you can start with, you start from there. Anywhere that you can start, and then you move with that. At least if question 5 is easy for me to do, I do it first. It gives me that confidence that at least I've done the first one, so there is still hope. All right, let's start. So we want to find this we want to find f prime using the limit definition. So we've done limit definition a lot of times, right? So that's what we just want to do right now, right? So we want to look at how we can do limit definition here. So let's start. So as I said, always we try to find f prime using either power rule or any of the rules that we know before we use the limit definition. So f prime is going to give us 12x plus 4. So when I differentiate this is what I'm going to have. So this is what I'm working towards using the limit definition. If you do this, you are getting it to be 0 because this is using the limit definition. So now let's go to limit definition. What's the formula? What's the formula? So f prime of x is equal to limit h is approaching 0, f of x plus h minus f of x all divided by h, right? So the only problem here is when you plug in the 0 here, this will just blow up. So what are we going to do? We just need to look for this, but we have this which is equal to this. So now we write f of x which is equal to 6x squared plus 4x minus 1, right? And then, as I said, with limit definition, I try to make sure that I put all the x in parentheses. Good. So when I do that, x is in parentheses. Same thing here, which will help me to find for f of x plus h. This one right here. So this is going to give us, now you see that x is in parentheses. That's why we can see x. So I'm going to write the same equation here, but change all the one in the parentheses to now x plus h. So I'm going to have 6x plus h squared plus 4x plus h minus 1. The parenthesis matters a lot, right? So now that we have this and this, I'll try and simplify this one. So we are going to have 6x plus h, x plus h, then plus 4x plus 4h minus 1. Let's try and expand this. This is going to give us x squared plus xh plus xh plus h squared plus 4x plus 4h minus 1. So what did I do? I'm just multiplying this by this, giving us x squared, right? Then x times h will be xh, and then h times x will be the same as xh, and then h times h will be h squared. And just repeated this one here. So what I'm going to do is I can simplify the one in the parentheses plus. So this it will give us 2xh plus x squared plus 4x plus 4h minus 1. All right. So this is going to give us, now I'll multiply the 6 through. So I'm going to have 6x squared plus 12xh plus 6h squared plus 4x plus 4h minus 1. This is going to give us, I think there is no term which is the same. So I think this is what you're going to get at the end of the day. Right. So now that we have f of x plus h and f of x, we can just simplify and find for f of x plus h minus f of x, right? So that when we are putting it in the limit, it becomes very easy for us. So let's look for f of x plus h minus f of x. So f of x plus h is equal to the whole of this. So I write everything 6x squared plus 12xh plus 6h squared plus 4x plus 4h minus 1 minus, then minus this, which is equal to this. So this, we have three terms, so I need to put them into what parentheses. So I'm going to have 6, I'm going to have 6x squared plus 4x minus 1. Simplify this, we are having 6x squared plus 12xh plus 6h squared plus 4x plus 4h minus 1. Then I multiply through the minus, I have minus 6x squared minus 4x plus 1. So plus 1 will cancel minus 1. Then minus 4x will cancel positive 4x. And then minus 6x squared will cancel positive 6x squared. So this is going to be left with 12x plus h plus 6h squared plus 4h. And then this is going to help us to write it as, so since we have h in common, we can factor h out, and we are going to have h out 12x plus 6h plus 4. Good. So that's what you're going to get at the end of the day. Good. So this is what we're going to get after we are done simplifying this. So all we are going to do is we are just coming to put that one there. So let's continue from here. We are going to have this one to be equal to limit h is approaching 0. Now everything here is equal to what we have here, right? Which is the same as this. So let's put it there. We had h 12x plus 6 plus 6h plus 4. Then we divided by the h. So we divided by this h here, right? So all this is just the hard work, all the things that we just need to go through. So now the magic happens, h will cancel the h, and guess what will happen here? So let me shift this one small to the left. So this is going to give us, okay, I think I can clean this one too as well. Good, so that I can write this one as, this is going to give us limit h is approaching 0, 12x plus 6h plus 4. And this is going to give us, now that there is no divided by h and this is a polynomial function, we can plug in the 0. And then with this one, we are going to have 12x plus, so let me just clean and bring it down. So we are going to have 12x, let me use red, 12x plus 6 times 0 plus 4, and this is going to give us 12x plus 4. And we can see that this result is the same as the derivative that we did here. So this helps us to confirm that, okay, what we did is indeed true. So anytime you want to do limit definition, try, if the function is polynomial like this, it's good for you to just do the differentiation, put it somewhere, and then when you are done, you just confirm with this one. Right, so that is just the limit definition. Let's look at question 2. So question 2 is saying that x and y are positive numbers, right? And we want to maximize this function such that x plus y is equal to 30. So what I'm going to do here is, first I'll let's say a to be equal to x squared y. And then I have x plus y is equal to 30, right? So this kind of like when you are given a fence, you want to, those kind of questions. So this, I can make y the subject, and I'm going to have 30 minus x. So I subtract x here, I subtract x here, and then I have this. Then I'll plug this one inside this, right? So let's do that. We are going to have a to be equal to x squared times 30 minus x, right? Because this is y. Then when I simplify this, I'm going to have 30x squared minus x to the power. So I can decide not to even simplify. Okay, let me simplify. So this one is going to give us x to the power 3. So this is our a. So for us to maximize, or for us to find the maximum value, then we need to differentiate a so that we can find the value of x to maximize this. So now what are we going to do? Let's differentiate. A prime is equal to 60x minus 3x squared, right? So now we want to look for the values of x that will make sure that this equation is equal to 0. Don't forget we are finding the critical values here. So we are looking for a prime to be 0. So I can pick 60x minus 3x squared to be 0. And then here, what I can do is I can factor 3, or let me say divide through by 3, and I'm going to have this one to be 20x minus x squared is equal to 0. So I divide this one by 3, divide this one by 3, divide this one by 3. Right, so this is what I'm going to get. Then what I can do here is I can factor x out, and it will be left with 20 minus x is equal to 0. So we can see from here that when x is equal to 0, indeed this will be 0, right? And then when 20 minus x is also equal to 0, our x will be equal to 20. So now we have two critical values. We have when x is equal to 0 and when x is equal to 20. But the idea is that we cannot maximize this with the x is equal to 0, because when I plug it in here, I'm going to get 0. So the value that we need to choose is when x is equal to what? 20. So we pick x is equal to 20. So now that we are picking this one, what we can do is, since we want to maximize this area, we are going to plug in this inside this so that we can get the y value, and then we find for the maximum area, right? Or the maximum of x squared y. So let me do that. So from here, I plug in x, and I'm going to have y is equal to 30 minus 2, and this is going to give us 10. So finally, what will be the maximum value? So the maximum value will be equal to a is equal to 20 squared times that. So what is 20 squared? 20 squared is going to give us 400 times 10, and this is going to give us 4,000. So this is the maximum value that we are going to get when x and y are two positive values. So you see that this is a positive value, and this is also a positive value. Right, so what did I do? Summary, I just let a to be equal to this, which is this, and then I chose this one here. Then I made y the subject. From here, I plug it inside this, which gave me this. I expanded this, and then I had this. Find the critical value by differentiating it. Find all the critical values. We pick x is equal to 20, and then we plug that in inside this equation to find for y. And then after we've gotten x and y, plug it in here to find the maximum value, right? So this is an exam question, so please pay attention and stay here. Let's go through together so that you'll be fine, right? So let's look at question 3. Find the following derivative. Do not simplify. Good. So this, we are just doing the derivative. This is a polynomial function and we don't need to do any simplification before we differentiate. So our y prime will be equal to, so we know how to do the differentiation. 4 times 9 is going to give us, I think, 36. Is that right? Yeah. And then x to the power 3 plus differentiate this and get 30 x squared minus 8. So polynomial function differentiation is very simple. Just use the power rule. 4 drops down to multiply the coefficient, subtract 1. 3 times this, subtract 1. And then when I differentiate x, I get 1. So I get negative 8. And when I differentiate 5, I get 0. So that's what I'm going to get. Now let's look at b. B is a product rule. So let's assign variables. Let's assume that this, we have a and we have b. And let's choose a to be equal to x to the power 6 and b to be equal to e to the power 2x. A prime is equal to 6x to the power 5. B prime is also equal to, when you differentiate this, you maintain the function, then we multiply by the derivative of the top, which is going to be 2. So this is going to give us 2e to the power 2x. Somebody can also do it direct, right? Using y prime, you can just write the final answer there. It's also right. So y prime is going to be a b prime plus a prime b. So what are we going to get? This is a is x to the power 6 times b prime is 2 e to the power 2, right? This is a, this is b prime. So we have it here. Plus a prime is 6x to the power 5, and then b is 2x. So a prime and b. So simplify that, and we have 2 out, 6 e to the power 2x plus 6, 5 e to the power 2x. So this is what I'm going to get. And you know that you can just do it straight. So somebody can just look at the equation and say that, okay, y prime will be equal to, I maintain x to the power 6 and differentiate e to the power 2, giving me 2, right? Plus, now I maintain e to the power 2x and differentiate x to the power 6, giving me x to the power 5. And then simplify, get 2x x plus 6x to the power 5 into x. So you see that this is the same as this. Any of them is okay, but the idea is that making sure that if we are passing through this point, or if we are using this, make sure you get it right. You don't make mistakes, right? And if we are not good with this, you can just pick your A and B on the safer side. Just multiply this by this and this by this, and you are okay to go. All right. Let's look at C. Let's look at C. Let's look at C. So C, we want to find the derivative, right? So what can we do? We can use the quotient rule, right? So quotient rule, I love using u divided by vin, right? So that my y prime will be equal to vin u prime minus vin prime u divided by vin squared. You can use, let's say, gen over f, and this is going to be f gen prime plus f prime gen divided by f squared. Any of them is right. You can also use f over gen, like the same thing. So any of them that you are going to use, we should get the same result at the end of the day. But choose the one that you like. Okay. I've been using u and vin throughout, and then the product rule too, I've been using a and b. So that's the reason why I'm doing it here. So this here implies that my u is equal to x plus 1, and my vin is equal to 2x squared minus 6, right? So that's what we have. Now what will be u prime? U prime is equal to 1, and vin prime is equal to 4x. So differentiate this, get 1, differentiate this, get 4x, but this is going to be 0, right? So that's what I'm going to get. I love using this so that all I know is when I write down my formula, just put them in, put them in. So now let's just put them in. This is going to give us, this is going to give us, we know that VIN is equal to this. So I have 2x squared minus 6 in parentheses. It's very important. What is u prime? 1. So times 1 minus VIN prime, which is 4x, times u is x plus 1. So x plus 1, all divided by VIN squared. So this is my VIN, and then I need to square that. So I have 2x squared minus 6 all squared. We can decide to simplify it small. The question is, do not simplify, right? So do not simplify means that you can just leave your results here and you are done. But if, assuming that you didn't see it and you want to simplify, then this is going to be 2x squared minus 6 minus 4x squared minus 1 divided by 2x squared minus 6 all squared. So this is going to give us minus 2x squared minus 7 divided by 2x squared minus 6 all squared. So that's what I'm going to get. But you can just leave your final results just right here and you are okay to go because do not simplify. Good. Let's do the last question on question 3. Then we move to question 4. All right. So we want to differentiate a length function, and we know that a length function is, so we have 6, which is a constant. So let's factor it out, right? So we know that for a length function or the natural log function, if we want to differentiate, we said 1 divided by what is inside the parenthesis, which is 3x minus 5 times now the derivative of what is inside the parenthesis. So d over dx of what is inside the parenthesis. Good. So this is going to give us 6 open bracket 1 over 3x minus 5 times, when I differentiate this, what am I going to get? 3, of course. So I'll have 6 times 3, and then this is going to give us 1/8 divided by 3x minus 5, right? So if you don't want to go through this, somebody can just watch it and say that, okay, y prime is equal to, okay, so I differentiate what is inside and I'm getting 3. So 3 times 6 is going to give me 18 divided by what is inside the parenthesis. It's also the same thing. But the idea is that when you are just doing it straight, doing the differentiation in your mind, make sure you write the right solution, right? Because let's assume that I'm marking and then this one, you just even did it, let's say 19. The possibility that I'll give you 0 is very high because the answer is not right. But let's assume that you went through this process and then maybe you are doing some multiplication, and then I will see that, okay, the person wrote the right thing, but it just multiplication error and write 90. So we can even get the 4 marks from there. So make sure that you provide solutions, or if you don't want to provide the solutions, to make sure you get them right. Let's look at question 4. So question 4, we need to find the indefinite integral. So indefinite integrals, don't forget to add your plus c, because if you don't add plus c, you get minus something depending on the question, right? So let's see how we can go through that. So this is a polynomial function. So we are going to have this one to be, so we are just doing integration. So don't confuse yourself with derivative and entire derivative, right? So this is going to give us minus 4x to the power 4 divided by, let me write it down here. So this is going to give us minus 4x to the power 4 divided by 4. So what is here is the same as this. So add plus 1, 3 plus 1 plus 6. This is going to be 3 divided by 3, then minus 7. X, don't forget this is to the power 1. So this one will be 1 plus 1, which is going to be 1 plus 1. So even let me just change this 2 plus 1, and this is 2 plus 1. This is going to be 3 plus 1, and this is also going to be 3 plus 1. Then plus, when we integrate the constant, we multiply whatever is here with respect to the x. So 1 times x is going to give us x. Or you have in mind, what function did I differentiate to get the 1? X. Then don't forget to add your big constant because it's very important, because this is indefinite. Now this is going to give us minus 4 x to the power 4 divided by 4 plus 6 x to the power 3 divided by 3 plus 7 minus x to the power 2 divided by 2 plus x plus the constant. So I think when you simplify, this is going to be minus 4 minus x to the power 4 plus 2x to the power 3 minus 7 over 2x squared plus x plus c. Good. So this is what we are going to get at the end of A. Let's look at this one. So you see that this one we didn't do any simplification and we did. But this we need to simplify it before we can go through. So this is the same as integration of 4e to the power negative 2x plus, so you see the way this one is, I can write this one as 7 over 9 times 1 over x, then all the x. Good. So you need to look at it very well. So this can be written as this, because when I multiply this by this, I'll have the 7, and this by this, I'll have the 9x here. So how do we integrate an exponential function? We maintain the exponential function, then we divide it by the derivative of what is on the top. So when I differentiate minus 2x, what am I going to get? Minus 2 plus 7 over 9, which is a constant. Then when I integrate 1 over x, what am I going to get? Now remember the function that when you differentiate, you get this, right? Good. That is the natural log of x. So this is going to give us the natural log of x plus a big constant. Good. So simplify this, and we are going to have minus 2 e to the power minus 2x plus 7 over 9 natural log of x plus c. So I said if it is indefinite and the power here is odd, then always we have it to be this form, right? So we put it inside the len function because it's indefinite. We don't know what is there. All right, so I think that's all for question 4 too. Yeah. Let's look at question 5. So first we want to find f prime. So let's do that. So what is f prime? Let's use the power rule. F prime will be 5x to the power 4 minus 3 times 15 is going to give us, I think, 60. Yeah, that's right. X squared. And when I differentiate this or take the derivative of this, I get 0. So this is the f prime. We are done. Now here we want to find the critical values, right? So we can get the critical values from the f prime. So we can decide to, since we want to find a critical value, we can decide to simplify this once more. So I can divide this one by 5, or I can factor 5 out, right? Good. And then I can factor x squared also out. So x squared out. So this one will be left with x squared, because when I multiply this one by this, I'll have this. And then 5 goes to 60. How many times? I think 12, right? Yes. So this is going to give us minus 12, right? So this is what I'm going to get at the end of the day. But let me check my 3, 5, 15. Oh, this is supposed to be 45. Good. So that's the reason why. So it's good to check. So you see, when you are not using calculator, sometimes your mind will just flip. So always make sure you verify things. Okay. Good. So when I factor 5 out here, then this one is going to be 9. Good. So this is what I'm going to get from the f prime. So for critical point, we said f prime should be equal to 0. So we actually want to make sure that this is equal to 0. I think I can even do one step here. So this is the same as 5x squared, and then this is the same as difference of 2 squared. So x minus 3, x plus 3. Right, so I can do difference of 2 squares from there. So what are the critical points? Critical points are the point or the values that makes this to be 0. So we see that it is not hard to see that when x is equal to 0, this will blow up to 0, because when x is 0, this will be 0. 0 times this will be 0. And then when x is equal to 3, when I put 3 here, everything goes 0. And then when x is equal to minus 3, this will blow up. But if you cannot see it this way to find your critical values, then what you can do is you set 5x squared x minus 3 x plus 3 to 0, right? Then we can see that 5x squared should be 0. So what can we see? We can see that I can divide 2 by 5 and have x squared to equal to 0. And the only value of x that will make sure that this is 0 is when x is equal to 0. Then you pick x minus 3 is equal to 0, x should be 3, and then x plus 3 should be equal to 0, and x should be equal to minus 3. So you can go through this, or you can use the eye testing to also can find this. So 0, 3, minus 3 are the critical values of f. Let's see C. So C, we want to check local maximum, minimum. So here we need to use the sign chart, right? So let's use the sign chart. So I have my sign chart here. Let me put the critical values on it. So the least critical value is minus 3, followed by 0, and followed by 3. So I have all the critical values here. Now don't forget we are using f prime. So let's write f prime on the top here. F prime of x is equal to 5x squared x plus 3 x minus 3. Right? Good. So we had a minus here and plus here, the same thing. So let's pick any value before minus 3, which will be minus 4, and then any value between minus 3 and 0, we can pick minus 1, and then between 0 and 3, we can pick 1, and here we can pick 4. So plug in minus 4 here. Now minus 4, since this one is squared, we don't even think about it, because whether positive or negative, it will make it positive. So we need to think about this too. So when it is negative, minus 4 minus 3 will be negative. Minus 4 plus 3 will be negative. So negative will be positive, meaning that this is greater than 0 and this is positive, increasing. Good. Plug in minus 1. As I said, when I plug in minus 1 here, this one will be 1, positive. When I plug in minus 1 here, this will be minus 4. But minus 1 here will give us 2. So negative, positive will be negative, meaning that this guy here is less than 0. So negative, and it is decreasing. Let's look at 1. When I plug in 1 here, this will be negative, right? And this will be positive. So negative, positive is still negative. So negative, this guy here is decreasing. Good. Then let's plug in 4. 4 here will be positive, 4 here will be positive. So this is greater than 0, and we have positive, and this guy is increasing. So let's see what is happening at x is equal to negative 3, 0, and 3. So x is equal to, let me write it out here. X is equal to minus 3 is kind of like this. Right here is kind of like this, positive, negative, so local maximum. So this implies local maximum. Now when x is equal to 0, you see we have negative negative, the sign is not changing. So at 0 we can surely see that there will be something like called point of inflection happening here, because this kind of, you are drawing the graph, when you get to 0 still go down before it turns up. So the point of inflections somewhere here, right? So we are going to have point of inflection somewhere. So at 0, neither of them, right? We don't have any point. So at 0, so at 0, um, no, no Extrema, right? So no Extrema. So we don't have any of them. And then x is equal to 3. This is kind of minus positive. So we are going to have the minimum. And this one is going to give us local minimum. Good. So that is what we just need to do. So you don't need to just pick the maximum and minimum and you are done. The question is, we want to classify the critical values. So we need to check 0, 3, and minus 3, all of them, right? So we need to classify all of them. Good. So that is question 5. We have 6 more to go. I hope you are enjoying it and I hope you are still here with me. All right, let's look at question 6. So question 6 is absolute maximum and absolute minimum. So it's nice that we did question 5 and we are doing question 6, because it's kind of always you need to pay attention to whenever we are talking about local maximum and the minimum, which goes with the first derivative and then the sign chart with all the critical points. So you should be able to differentiate yourself from local maximum, minimum, and then absolute maximum and minimum. Let me clear that out. So with this one to go through the same process, we need to find the critical values by finding the derivative. So what will be gene prime of x? We have our gene to be equal to this. So this is going to give us 4x to the power 3 minus 16x. So let's find the critical values. We can simplify this. I can factor 4x out, and this one will be x squared minus 4, right? I think this also can be written as 4x, difference of 2 squares, x plus 2, x minus 2. So what are the critical points? So critical point is when gene prime of x is equal to 0. So whenever you plug in the x, this should be equal to 0, right? So we can see that when x is equal to 0, when x is equal to minus 2, and when x is equal to 2 from here. Right. So we have the critical point. Not like this, that when you finish, you need to put all the critical points on the number line or on the sign chart or the sign graph or the diagram. Here is not how we are doing this. This, we need to look at the domain before we can even pick the relevant critical values. So the domain is from minus 3 to 1. So you ask yourself, is 0 inside minus 3 to 1? Yes. Is that there? No. Or yes? Yes. Okay. So 0 is there. Do we have negative 2 inside the domain? Also yes. Do we have 2 inside the domain? No. So this guy here is out. So we are going to use this, and then the endpoint to find for maximum and minimum. But this one, we don't use sign chart, we use the graph. I mean the table, right? So we have this table. We have x. What are the endpoints? Minus 3 up to 1. But in between, we have minus 2 and 0. So minus 2 and 0. So that's the reason why they are in. So when you want to pick the 2 be here, what is not in between minus 3 and 1. So don't forget to here to we use the original function, not the derivative function. So this is gene. So let me use gene. So we need to find for gene of negative 3, gene of negative 2, gene of 0, and gene of 1. Good. So let me write my gen of x here. Gen of x is equal to x to the power 4 minus 8x squared. Good. So I love zeros. So 0 is going to make sure that this guy is equal to 0. Let's plug in 1. 1 is going to give us 1 minus 8, and this is going to give us negative 7. Let's plug in negative 2. Negative 2 here will be negative 2 to the power 4 minus 8, negative 2. So this is 2 times negative 2 times 2 times negative 2 times negative 2. So this will be 4, this will be 4, 16, right? So you have 16 minus 2 squared is 4. 4 times 8 is going to give us 32. Yeah, I think so. So subtract, and this is going to give us negative 16. So negative 16. Okay. Let's do the last one, which is negative 3. So plug in negative 3 here, and we are going to have minus 3 here. X to the power 4, I think, supposed to be 8 to 1. I think so, but let's just do it. So negative 3 times negative 3 times negative 3 times negative 3. This is going to give us 9. 9. 9 times 9 is 81. Yeah, so that was right. Minus 8 times negative 3 squared is 9. Then guess what? 9 times 8 should be 72. Yeah, which is right. So subtract 72 from 81, and we are going to have 9. So this is going to give us 9. So now locate absolute maximum, and we can see that the maximum will happen here, and then the minimum will happen here. Good. So that is what we are going to get at the end of the day. All right. All right. So let me just write. So now absolute maximum is 9 at s is equal to minus 3, and then absolute minimum is a big negative 16 at s is equal to minus 2. Good. So this is what we are going to get for question 6. Good. Let's look at question 7. Question 7. So this kind of, all the questions are mixed up, so we are just doing them together. So this is a definite integrals, and then sketch and shade. So for us to do the sketching, we try to make sure that this function, we define this function. So let's assume that that function is f of x, which is equal to 3x squared plus 2, right? Then what we just need to do is we need to look for this and that. So let's assume that that one is a and this is equal to b. So let's create a table and put here to be x and put here to be f of x. So minus 1 and 3. So let's look for f of minus 1 and f of 3 so that we can use it to sketch the graph. So plug in minus 1 here. What do you get? So when I plug in minus 1 squared will be 1. So 1 times 3 is 3. 3 plus 2 is going to give us a big 5. Then plug in 3. 3 squared is 9. 9 times 3 is, oh, I think this one's supposed to be 2. Good. So plug in 2. 2 squared is 4. 4 times 3 is 12. 12 plus this is going to give us 14. So this is the point that we have. We have negative 1 and 5, and we have 2 and 14. So let's try and sketch it on the graph, right? Let me just move this, my table, to this right corner here. So let's look at the point. We have negative 1 and 5. So let me assume that I have 2, 4, 6, 8, 10, 12, 14. So 2, 4, 6, 8, 10, 12, 14. So I have -1, which goes with 5. So -1 and 5 will be, so let's assume that here is 5. So my point will be somewhere here. Good. Then I have 2 and 14. But let me sketch this one first. Good. Then I have 2 and 14. So 2 and 14 up there. So let me just shift this guy also here. So 2 and 14 will be somewhere here. So let me draw my line. So it means that my graph is going to be something like this. Let me join this point and then another point here, down here. So sketch and shade. So now we can shade this nice graph here. So we are going to have something like this. Good. This is nice. Good. So this is the graph that we are having. So remember, if you want to do this, you can use either dividing this one into 2 to having A and B, or A1 and A2, and then you do it. Right. So this is the first question. Sketch and shade. So we're able to do that. Now calculate the integral. So here we have two options because it's just straightforward. We can use a fundamental theorem to do this, or we can just use this one to find the area to do that. So if we want to use the area form, then we can divide this one to be A, right? This one to be A, and this one to be B, right? So now first, what is the distance from this side to this side? Don't forget this is 5. And then what will be the distance from this side to this side? This is equal to 3, right? And then you ask yourself, if from here to here is 5, then from here to here is going to be 40 minus 5, which is going to give us 9. So from this side to this side is going to give us 9. So if we want to do that, then the integration, let me write it down. From -1 to 2, 3x squared plus 2 dx. This is going to be area A plus area B. So what is A? A is a triangle, and we know that it is half base times height. So it's going to be half times the base is 3, and then the height is 9. So we are going to have 3 times 9, which is 27. So we are going to have 27 divided by 2. And B is a rectangle, which is base times the length or the height. So B times H, and this is going to give us 3 times 5, and this is going to give us 15. So the area is going to be 27 divided by 2 plus 15. Then as I said, divide this one by 1, this will multiply this will multiply this, divided by this times that. So I'm going to have 27 plus 2 times 5 is 30 divided by 2, and this is going to give us 57, right, divided by 2. So this will be the integration, right? And then you just do it. So this one, it's advisable for you to use the graph area to solve it, because since they've asked you to sketch, then you should be making use of that. Or you can also just do the integration straight here to check if you are going to get something like this. Right. Okay, so this is question 7. We have 4 more questions to go. So let's look at question 8. Question 8 is equilibrium point. Right. So we have a demand function, right? And then the question is asking us to find the x No, the question is asking us to find the equilibrium point. So at equilibrium point, we know that S of x should be the same as d of x. So this is f of s of x and this is d of x. So we are going to have x squared plus 15 should be the same as 4, 5 minus 13x. So simplify this. I'll do plus 13 here. I'll do plus 13x here. So I'm going to have plus 13x. Then plus 15. I'll do minus 45 here, minus 45 here. So I'm going to have minus 45 is equal to 0. Or in other words, I just move negative 13 to this side and it become positive because crossing this. Then I move positive 45 to this side become negative. So this is going to give us x squared plus 13x minus 30 to be equal to 0. So this is what we've gotten now. So now let's try and figure out the x values. I'll continue from this space. So this is the same as x squared plus two values that when I multiply I'll get 30, but when I add I get 13 can be 15 and 2, right? Because 15 times negative 2 will give us negative 30, and then 15 minus 2 will give us 13. So this is perfect. So now when I factor x out, I will have x out here. It will be left with x plus 15. And then when you factor minus 2 out here, we are going to have minus 2x plus 15 is equal to 0. Then we have x plus 15. Then x minus 2 is equal to 0. So this one is clear for us to see that x should be equal to minus 15 and x should be equal to 2. But here we say pick the positive one, x is equal to 2, right? So we are going to pick x is equal to 2, right? So the interception, like you should be able to go through this process to find that. So now that we've picked x to be equal to 2, we can plug x equal to 2 inside this or this to find for the price or the y aspect. So x of 2 is equal to 2 squared plus 15, and this is going to be 4 plus 15, and this is going to be 19. So the equilibrium point is 2 and 19. Good. So that's what we are going to get for the equilibrium point. Good. So you should be able to practice on this one too as well. Now write the integration to determine the consumer surplus. Do not calculate it. So one thing that one hint or tip that I'll give it to you is always, even if you cannot sketch the function here, right? What you need to know is, demand and supply function, the graph is kind of in the form demand goes in the negative direction and then supply goes in the positive direction, right? Positive inverse. So this is supply, this is demand, right? This is demand. So when you are done, then don't forget to know that we are going to divide this one into 2, and then the first one here is a um, consumer surplus, no, producer surplus, and then this one here is the consumer surplus. So don't forget the consumer surplus is always on the top. I think let me sketch this one big so that you can see it well. So I have this, and then I have my demand line, and then let's assume that I have my supply line too. So here, so this is kind of something like this. This line here is the one giving us the equilibrium point. So the equilibrium point is like 2 and 19. But the 19 is this line. This line here is 19. on this line. So this line here is 19. So this portion is the producer surplus and this portion is the consumer surplus. Right. So for us to get the consumer surplus, then as I said, this is going to be integrating from this line. So this line here is the first term here, which is 2, and this is basically 0. So we are going to integrate from 0 to 2. Then don't forget the equation I gave you. This is above minus below, right? So let me just write it. Above minus below the x. So what is the above here? So let me just write. What is above? Look at the consumer surplus. We have two lines. We have this, which is the above, and then we have this, which is below. So above is the demand equation, right? We are looking at the area here. So this is the above demand equation, which is 45 minus 3x minus below. Below is the equilibrium line, right? This one, which is 19. That is when y is equal to 19. So this is going to give us 19 x. So the question is saying that we shouldn't calculate. So we are not going to do that, but I think we can just simplify one step. So this is going to give us from 0 to 2, subtract 19 from this, and we are going to have, I think, 24 minus 13x dx. That's all. That's all that we need to do from there. We don't need to do the integration. Right. Then what do we need to do again? Is this supposed to be 24? 19 minus this, 15 here. It's supposed to be 26 here. 26. Good. So now let's look for producer surplus. So producer surplus, so this is consumer surplus. Producer surplus is also the same from 0 to 2, above minus below. So the same thing, but something will change here. So this is going to be from 0 to 2. What is the above? Look at the producer surplus. So above is this. So that one comes with the 19 first minus below. Below is the supplier curve, right? This. So what is the supplier curve? X squared plus 15. So x squared plus 15 or the x. So that's what we're going to get. And if we want to simplify, we can do that. We can have this one to be the same as, let me shift this one small here. This is 0 to 2, 19 minus x squared minus 15 or the x. And I think if I want to clean the above and below and simplify, we are going to have something like this. This one is going to be PS to be equal to this guy right here, and pick this guy right here, and this is going to give us from 0 to 2. This is going to be 4 minus x squared dx. So this is going to be the producer's surplus. So as I said, if you cannot sketch, or if you don't want to sketch, what you need to know is for the consumer surplus is always the demand function minus the, when you come to the equilibrium point, the second coordinate. That's what you need to remember. The demand function minus the second coordinate of the equilibrium point. And then the producer surplus is the second coordinate in the equilibrium point minus the supply function. And then you are done with that. Let's look at question 9. Let's look at question 9. The revenue function is this. So we have a revenue function. Let's write it down. 100x squared plus 7x. And then, okay, we increase from x is equal to 5,000 to 7,000. So then how much do we expect the revenue to increase by? Okay, so it's kind of if we want to look at when we increase x from x is equal to 5 to x is equal to 7. But don't forget, this is 5,000, this is 7,000. So it's very simple. All we need to look for is the change in revenue, or the expected revenue will be equal to R of 7 minus R of 5. I mean, we are trying to look at, okay, what is the revenue at x is equal to 5? That is 5,000. So this is like 100 times 5 squared minus 7 times 5, right? So what is R of 5? So this is 100 times 25 minus what is 7 times 7,000 times 700 times 5? This should be 3500. Yeah, I think. And then this is going to give us 2500 minus 355. Is that right? Oh, the revenue function is positive. So when you add this one, we need to get something like 6,000. So this is the revenue that we are going to get at x is equal to 5. But the question is, now we are changing it to x is equal to 7. So when I change it to x is equal to 7, see what is going to happen here now. So it means that now I'm going to have R of 7, right? So since we've gotten this one to be 6,000, I can clean this one and then shift this guy up here so that I can pick this one here. So this is going to be 100 times 7 squared plus 700 times 7. So 100 times 49 plus 7 is 49, right? So we are going to have 4900, and then this will be 4900 plus 4900. So basically this should be 9,800. Good. So you see that when x was 5, we had 6,000, but don't forget, it's not just 6,000, we have another 1,000. So this is like 6 million, right? And then when we change it to x is equal to this, we are having this. So we want to look at the expected increase. We want to look at the change, right? So the change of revenue is going to be 9,800 minus 6,000, and this is going to give us 3,800, right? So this is what we are going to get at the end of the day. So it means that when we increase x from 5 to 7, this is what we are going to get. But don't forget, this is going with 1,000, so it's best for me to write 1,000 in addition. So that's what you are going to get. So the interpretation can be like the revenue increased by this, right? When the chip sales, right? The chip sales increase from 5,000 to this. That will be the interpretation, but it's good to just end it here. We have 2 more questions to go. 2 more questions to go. Oh, I love this. Okay, good. I love these questions. I love them. So let's look at question 10. We have a function like this. So kind of we need to switch our mind with kind of the first thing that we are doing to, partial derivatives. So first we want to find both first derivatives. So this here and that one here. So what is differentiating f with respect to x? So as I said, when we are differentiating this with respect to x, if the function is not in terms of x, we are assuming that it's a constant, and when we differentiate a constant, it should be 0. So when you look at this, we have x here, we have x here. This has no x, this has no x, this has no x. So when I differentiate this, it will be 0, this one will be 0, this one will be 0. So fx is going to be, now differentiate this, let's do the normal differentiation. This is going to be 2x. When I differentiate this, I'll get 0, so plus 0. plus. Now this is, we have x here. So when you differentiate x to the power 3, what do you get? So since I have x to the power 3 here, I'll pull out my 2y and then differentiate x to the power 3, which is going to give me 3x squared, right? So this is not going to get 0 because we have x in. So I have a constant which is 2y. I pull it out and then differentiate x to the power 3. I have this minus 0 plus 0. Simplify this and we are going to have 2x plus 2 times 3 is going to give us 6. So 6x squared y. Good. So that is when I differentiate it with respect to x. That's my final answer here. Let's look at when it is with respect to y. So when it is with respect to y, now I look for the functions with y. So this is y, this is y, what is y? So it means that the one without x, without y, when I differentiate, I need to get 0. So I'm going to have 0 plus. When I differentiate this, I'm going to have 3y squared. Now don't forget, we are not going to add any prime or those things because we are differentiating with respect to y. So we have this. Then when I differentiate this, I maintain 2x to the power 3 as my constant and differentiate the y here, and I'm going to get 1 minus 9. I factor my 9 out and I differentiate y squared, and we are going to get 2y. So when you are differentiating a y function, you can think of you are differentiating x function, right? So when I differentiate x squared, I get 2x. So when I differentiate y squared, I need to get 2y. Then finally plus 0. So this is equal to 3y squared plus 2x cubed minus 18y. So this is what you're going to get at the end of the day. Now, the surprise thing here is now this fx will give birth to this guy and then also give birth to this guy. Good. So it means that when you get this one wrong, automatically this and this will be 0. I mean, you get it wrong too as well. Why is this giving birth to this and that? The idea is that you can see that, let me just clean the math small here. You can see that this is fx. We can see fx here, and we can see fx here. So because of that, the idea is that now we are going to differentiate fx with respect to x. Clear. So we have fx, and we have the x here. So it means that we need to differentiate fx with respect to x. What is fx? Fx is equal to what is here. So now let's differentiate this with respect to x. I have x here, have x here. Good. So this is going to give me 2, because when I differentiate x, I'm going to have 1 plus. I have x here. I have my constant. I factor them out, 6y, and differentiate x squared, 2x. Simplify, we have 2 plus 12xy. Good. So that is f of xx. Let's look at this one. Now we differentiate fx with respect to y. So now we differentiate this one with respect to y. So we need to think about the one with y. So this is with y. This has no y. So that one will be 0. So this is going to give us 0. Then plus. I'm differentiating with respect to y. So I'm going to have 6x squared times 1. As we can see here. 6x squared times, I differentiate this one, I get 1. So this is going to give me 6x squared. Good. Now, this y here is also going to give birth to this 2 here. Why? Because we have fy, we have fy first, another fy first. So for us to do this, we need to get this one. So it means that when you get this one wrong, what we are coming to do here to be wrong. right? So now we are differentiating fy with respect to x. So we want to differentiate this with respect to x. So what are the x terms? We just have only x here. So it means that when I differentiate this, I'll get 0. When I differentiate this, I'll get 0. So let's do it. Then I'll put the answer down here. So this is going to give us, differentiate this one will be 0, plus when I differentiate x, 2x to the power 3, I'm going to have 6x minus 0. So that I can bring it down there because our thing is down here. So now this is going to give us, oops, I think this, when I drop it, it should be squared, right? So this one should be squared. So this is going to give us 6x squared. And you can see that this guy is the same as this guy. So we are saying that f of xy is the same as f of yx, symmetric, right? So if we don't get this to be the same as this, then there's something wrong from there. Then now finally we need to differentiate y with respect to y. So we differentiate this with respect to y. So now we have y here, we have y here. So let's do that. This is going to give us 6y plus 0 because there is no y here. Then when I differentiate this, I get minus 18 times 1. So this is what I'm going to get. So let me send it down there. Good. So this is going to be this. And this is going to give us 6y minus 18. Interesting. So this type of questions, if you practice very well, and if this one is 10 points, 9 points, you should be able to get everything right. Everything right. Let's do the last question and then we are done with this video, right? Question 11. Question 11. All right, so question 11 is saying that find the critical point of gen of xy, right? So this is the partial form. So it means that for us to find the critical point, we need gen of x to be equal to 0, and then we need gen of y to be equal to 0. So that's the two things that we need. So now first, for us to do that, we need gen of x. So let's differentiate this with respect to x. We are going to have x here, x here. The rest has no x. So this is going to give us 2x plus 4, right? This one will be 0, this one will be 0, this one will be 0. So you just differentiate this and we have that. Then what is gen of y? Now we look for the one with y here, y here. So this is going to give us 2y minus 6. Interesting. So for critical point, this should be equal to 0 and this is also going to equal to 0. So we are so fortunate. Why am I saying that? It's because x plus 4 is equal to 0. This one is in terms of only one variable. So we can just find for x here. We don't need to solve for, so let me write this one too. Y minus this is equal to 0. This is in terms of only x. This is in terms of only y. So we don't need to solve it simultaneously like what we've been doing in class, right? So what we just need to do is we just need to find x here. So this is 2x is equal to minus 4. Positive 4 plus the equal to sign become negative. Divide through by 2 and x will be equal to minus 2. Same thing here. 2y will be equal to 6 and then divide through by 2 and y will be equal to 3. So the critical point is minus 2 and 3. That's the critical point. So the reason why I was saying that we are fortunate is like kind of this is in terms of only x, because we can have equation where we have 2x plus let's say y is equal to 0 and then another 3x plus let's say 5x is equal to 6, and then we need to solve this equation and this equation simultaneously. So that is the idea, but we were fortunate enough that this was in terms of only x, this was in terms of only y, so it helped us to find a critical point. So now the question is classify the critical point you found in A as a local minimum, maximum, or a saddle point. So how do we do this? We know that we can get this from d of x, y. Some people can use the idea of f of x, x, f of x, y, f of x, y, f of y, y, right? But don't forget, this is kind of, you are finding the determinant. So even, let me just make this one like this. So this is kind of, we are finding the Jacobian, like the determinant like this. So this times this is going to give us f of x, x, y, y, minus this times this is going to give us f of x, y, all squared. So any of them, you are right, right? So now I can use the idea of d of x, y is equal to what is here. So I'm going to have x, x, y minus f of x, y, all squared, right? So it means that we need f of x, x, f of y, y. Okay, so the function given to us is in terms of gene. So let's use gene instead of x, instead of f. So gene, and this also gene. Good. So we need to change this ones too. So this one is going to be a gene. Same thing to this one. Good. And then this one too as well. This one too is going to be gene. Okay. So next time we need to look at the function before. So now we need gene of xx, gene of yy before we can even plug in the critical point. So let's do that. Gene of x was this. So what will be gene of xx? So gene of xx is, we need to differentiate this with respect to x, and we are going to get 2. Gene of yy, we need to differentiate this with respect to y, and we are going to have that one to be 2. Okay. Now we need to differentiate this with respect to y. So gene of xy is going to give us, there's no y, so this will be 0. Let us confirm it from this side too. Gene of yx, when I differentiate this with respect to x, I get 0. So you see that this and this are the same. So it means that this is going to give us 2 times 2 minus 0 squared. And this is going to give us 4 minus 0, and this is 4. So this is d of xy. Now we are checking it at the critical point. So we need to plug in the critical point. So let's do that. Critical point is -2 and 3, right? Yeah. So since this is equal to 4 and does not depend on x, when we plug in the critical point, still we are going to get 4. And guess what is happening here? Now we can see that this guy here is positive. So we are saying that since d is positive, so since d is positive, we can see that saddle point is out because this is positive. So it's either minimum or maximum. But we need to compare d and gene of what? xx. This is positive. So since d is positive and gene of xx is also positive because it's equal to 2. So this is equal to 2 and positive. Then what do we have? Then the critical point, 2, 2, the critical point, the critical point, 2, 2. What's the critical point? Critical point is -2 and 3. So let me move, let me shift this guy here so that I can finish my conclusion. 2, 2 is a local minimum. Good. So this is positive. This is also positive. So we are going to have a local minimum. Good. So I think this is the end of the video, and thank you so much for staying here and then learning with me. So basically, When you are done, you can just get the worksheet or you can just get all the questions and then also try it yourself again. Try to solve them as you've gone through the whole solution here and try to see how you can also go through the solution as well. Don't forget to check exam 1, exam 2, and exam 3, and then the finals. So if you're able to combine this one and then you go through the review, I think you should be okay for the finals. All right. I wish you all the best and see you in the next video. Or you are telling me that you are done with business for calculus? Okay, fine. Maybe see you when I see you. Bye.